Section 11.1 is on areas of parallelograms and triangles. The formula for the area of a parallelogram is A equals BH, where B is the length of the base, which is any side, and H is the height, that is the distance between the two parallel bases. So taking a look at this parallelogram we have right here, this segment across the bottom is the base, and the dashed line going up and down, which is perpendicular to the bases, is the height. So let's try an example here. It says find the perimeter and the area of parallelogram ABCD. So since this is a parallelogram, I know that opposite sides are congruent. So this is 32 inches, and AD is also 20 inches. So to find the perimeter, I'm just going to add up all of the sides. So the perimeter is 2 times 32, that's the top plus the bottom, plus 2 times 20, that's the left plus the right, and that adds up to 104 inches. And notice that's not squared, that's in linear units because we're measuring the distance around. Now, in order to find the area of the parallelogram, I need to know what is the height, what is this distance right here, okay? And you'll notice that that is actually one leg of a right triangle here. So I'm going to use the Pythagorean theorem. 12 squared plus h squared equals 20 squared. Notice that the slanty side on the left is the hypotenuse of a right triangle. And solving that, I discover that h is equal to 16. Now to find the area, I'll do base, which is 32, times the height, which is 16, or 512 inches squared. And remember that area is square units because I'm basically multiplying 32 inches times 16 inches. Inches times inches is square inches. Let's take a look at another example here. Find the area of parallelogram ABCD. So here we have, let me go ahead and label the opposite sides again. So I know this is 12 at the top, although I don't think I'm going to need that. That's my base. I know that this side over here is 9. But what I'm noticing is that I have a 45, 45, 90 right triangle right here. And while it may not look like it, this height here is actually the same length as this segment of the base right here. So I'm going to label that H and that H. So I'm going to use my formula from chapter 8, I believe it was, that says that the hypotenuse of a 45, 45, 90 is equal to the leg times the square root of 2. In this case, the hypotenuse of that triangle is 9. My leg is h times the square root of 2. Solving that for h by dividing both sides by square root of 2. My height is 9 over square root of 2. Rationalizing the denominator. My height is 9 square root of 2 over 2. And I'm going to leave it at that for right now. So that's this value right here. And using my formula for the area of a parallelogram, base times height, my base is 12. My height is 9 square root of 2 over 2, which comes out to be 54 square root of 2, which is approximately 76.4. And since I don't have inches or millimeters on this, I'm just going to use the word units squared. So be on the lookout for special right triangles in parallelograms. Formula for the area of a triangle. You probably already know this one, but it's A equals 1/2 B times H, where B is the base, which is any side of the triangle, and H is the height, the length of an altitude drawn to the base. So here in this triangle right here, I have my base across the bottom. The height is the length of this altitude that's drawn from the vertex at the top, perpendicular to the bottom. Let's take a look at this example. Find the perimeter and the area of this triangle. So the triangle I'm focusing on is the one that's outlined in dark lines. And then these dashed lines over here, I'm going to need to use those in order to find some of the values of the triangle on the right. So this segment right here is actually going to be the height of my triangle, but notice that that is also a leg of a right triangle right here, so I'll be able to use that, the Pythagorean theorem, to find that height. And then this side of the triangle over here on the right is the hypotenuse of a right triangle, so I'm just going to label that C. I'll need to find that value to find the perimeter. So let's go ahead and find H first. So using the Pythagorean theorem, h squared plus 6 squared equals 13 squared. And working that out, I get that h is equal to the square root of 133, which is approximately 11.5. Okay, so to find the area of this triangle, I'm going to do 1/2 times my base, which is 29, times my height, which is approximately 11.5, or my area is approximately equal to 166.75 centimeters squared. Now, in order to find the perimeter of this triangle, now I know what h is, but I need to find c. So I'll use the Pythagorean theorem again. I'll do 29 squared plus this height squared, and I'm going to go back to 133 and square that, is equal to c squared. And working that out, I get that c is equal to the square root of 974, which is approximately equal to 31.2. So for my perimeter, and this is going to be approximate, I'll add 29 plus what I found for h, which is 11.5, plus the value I found for c, 31.2, or my perimeter is approximately 71.7 centimeters. Okay, and here's a couple word problems that are kind of fun. So this one says the height of a parallelogram is 4 millimeters more than its base. If its area is 221 square millimeters, find its height and its base. So first thing I'm going to do is draw a little sketch of a parallelogram here. And let's draw the height. And so this is my base, this is my height, and my problem says that the height is 4 more than the base. So my height is 4 more than the base. So let's write the formula for the area of a parallelogram. Area equals base times height, and plug in the values we know. My area is 221, my base is b, and my height is b plus 4. Distributing, I get 221 is equal to b squared plus 4b. And I notice that this is a quadratic equation because it has a squared variable in it. So I will make it equal to 0 by subtracting 221 from both sides. And using the quadratic formula, I get that b is equal to 13 and b is equal to negative 17. But I have to throw out negative 17 because that's the length of the base and it can't be negative. So my base is 13. Going back to my diagram, my height is base plus 4. So my height is 17, and these were millimeters. Okay. And our last example involves a triangle. The base of a triangle is twice its height. If its area is 49 square feet, find its base and its height. So again, let's do a sketch. Here's my base. Here's my height. And it says the base is twice the height. The base is 2 times the height. Formula for the area of a triangle, 1/2 base times height. It's given that my area is 49 square feet times 1/2 times my base, which I'm going to call 2h, times my height, which is h. Let's work this out a little bit. So 49 is equal to 1/2 times 2 is just 1. H times h is h squared. Taking the square root of each side, my height is 7. And my base is 2 times my height, so my base is going to be 14. And each of these, the units on these were feet. So you are probably familiar with the formula for the area of a triangle. You probably already know that one, but it'd be a good idea to commit the formula for the area of a parallelogram to memory.